Hello again, and welcome to another virtual class. Today what we're going to do is we're just going to continue using the kinematic equations, and I'm going to try and give you some tips on using those. It's going to be a really short lesson, so hopefully you're not disappointed. Okay, so like I said, today what we're doing is we're just going to review using kinematic equations, and I'm going to give you a little hint, a little tip. First, let's do an example problem. So read this over and try it on your own, and then check back and see if you got the same answer I did. So when we read over the problem, first thing we do is draw some kind of a diagram to show what we know and what's happening. So our object is moving to the right, we'll say, in the positive direction, and we know that it's going to go 175 meters. From there, we're going to write down all of our knowns and unknowns. And there is one hidden known: stops. It says the object stops. All right, what does that imply? Well, that implies that there's zero speed or zero velocity at the end. So if we're going through everything, we have our initial velocity, our final velocity, and how far we go. And we're looking for acceleration. So then you have to look over all your equations and decide which equation is going to work. Well, in this case, you could use two different equations and solve for two different things. But in this case, if we use this equation, we weren't given any times, and this equation doesn't need time. So from there, we just substitute all of our values in, and we end up with a value of acceleration of negative 1.15 meters per second squared. So here are all of our equations. But if you noticed when you were using them after last class, hopefully you noticed that something was missing. There was a missing variable in each one of these different cases. So if we look at all of these variables that we have here in all these different equations, there's at least one that's missing in each case. So this first case, if you look and think about what's missing, it's our delta x. That first one has nothing to do with position. All it tells us is velocities, accelerations, and times. There's no position in it. The second one, can you pick out what's missing in that one? This one is the acceleration. There's no acceleration in this equation. What about the next one? It's a little bit more tricky to find it in the next one. Well, this one, it's a little tricky because we have position, we have acceleration, we have times, we have velocities, but the thing we don't have is we don't have final velocity. So we don't have anything about our final velocity. And then lastly, my favorite equation, and I like to say it's because it has no time. When we have no time for anything else, we use this one because time is the missing variable. So the reason this is helpful is because when you're writing out everything, if you write out all of your variables, you can quickly figure out which one was not given to you, and you know you don't have to use that equation. Or you know that's the equation you're going to go for because that's the variable that's missing. In a normal class, we would do a picket fence lab. I don't have a way to replicate this. I was trying to come up with a way, but there just really isn't a good way to replicate this because you use software and stuff that you guys don't have access to. So I'm going to assign a practice problem for you. So make sure you do that practice problem, and yeah, I'll see you again on Thursday. Email me if you have questions.